If all the oceans dried up, we'd be looking at the most catastrophic transformation of Earth imaginable. And I'm not just talking about no more beach vacations. I mean the complete collapse of life as we know it. This isn't some distant theoretical problem either. Understanding what would happen if the oceans disappeared helps us appreciate just how crucial they are to literally everything on this planet. So let's paint this nightmare scenario together. Imagine waking up one morning and the oceans are just gone. First thing you'd notice? The smell. Oh my God, the smell. Billions of tons of dead marine life rotting in what used to be ocean basins. Every fish, every whale, every tiny plankton organism, all decomposing at once. We're talking about roughly 3 million cubic kilometers of water that contain an estimated 1 to 2 million species of marine life. The stench would be unimaginable and would spread across continents carried by winds that no longer have ocean moisture to moderate them. But that's just the beginning. See, oceans aren't just big pools of water. They're the planet's climate control system, its thermostat, its air conditioner and heater all rolled into one. They absorb about 90% of the excess heat from global warming. Think about that for a second. All that heat we're pumping into the atmosphere, the ocean has been quietly absorbing most of it, storing it in its vast depths. Without them, temperatures would go absolutely haywire. We're talking extreme temperature swings that would make current climate change look like a minor inconvenience. The specific heat capacity of water is incredibly high, which means it takes a lot of energy to change water's temperature. This property makes oceans perfect heat batteries. They warm up slowly and cool down slowly, which stabilizes global temperatures. Remove that thermal mass, and you lose all temperature regulation. Days would be scorching hot as the sun beats down on land with no ocean to absorb that energy. Nights would be frigid as heat radiates back into space with no ocean to release stored warmth. The water cycle would completely break down. No oceans means no evaporation, which means no clouds, which means no rain. Well, at least not in the way we're used to. Currently, about 86% of global evaporation happens from the ocean surface. That's roughly 500,000 cubic kilometers of water cycling through the atmosphere every year. Any remaining water sources like lakes and rivers will become the only sources of moisture, and they'd be evaporating like crazy without ocean systems to regulate temperature and humidity. But here's the thing, they contain only a tiny fraction of Earth's water. All the world's rivers combined hold about 2,000 cubic kilometers of water. The Great Lakes hold about 23,000 cubic kilometers. Compare that to the 1.3 billion cubic kilometers that used to be in the oceans. Now here's where it gets really interesting from a geographical perspective. The ocean floor would be exposed, and you know what? It's not flat down there. Not even close. We'd see underwater mountain ranges taller than the Himalayas. The mid-Atlantic ridge stretches like a massive scar down the center of what used to be the Atlantic, running for 16,000 kilometers. In some places, this ridge rises 7,000 meters above the surrounding ocean floor. There are trenches so deep that if you stood at the bottom of the Mariana Trench, you'd be standing more than 11 kilometers below what used to be sea level. That's deeper than Mount Everest is tall. You could drop Mount Everest into the Mariana Trench and still have over 2 kilometers of water above it, normally. These newly exposed land would be covered in salt deposits, feet thick in places. When seawater evaporates, it leaves behind about 35 grams of salt per liter of water. Multiply that by the entire ocean, and you've got roughly 50 million billion tons of salt coating the former ocean floor. The minerals and sediments would create bizarre alien landscapes. Think about the Dead Sea region, but multiplied by millions. You'd have vast salt flats stretching for thousands of kilometers, mineral deposits in every color imaginable, manganese nodules scattered across the abyssal plains like bizarre metallic potatoes, and the fossilized remains of countless marine creatures embedded in the seabed. Hydrothermal vent systems, those bizarre ecosystems that exist around underwater volcanic vents, would suddenly be exposed. These alien-looking communities that survive without sunlight, powered by chemosynthesis rather than photosynthesis, would die out instantly without the crushing pressure and specific chemical conditions of the deep ocean. We'd lose unique life forms we're still discovering, organisms that have taught us that life can exist in conditions we never thought possible. But let's talk about what this means for life. Oceans produce about 50 to 80% of Earth's oxygen through phytoplankton. These microscopic organisms, invisible to the naked eye, are doing more for your breathing than all the rainforests combined. Every second breath you take comes from the ocean. No oceans, no phytoplankton, and suddenly we've lost half our oxygen production. The atmosphere would start changing composition pretty quickly. We're not talking about immediate suffocation, but over months and years, oxygen levels would decline, while carbon dioxide levels would spike. Land plants would struggle to compensate, but they'd be dying too because of the radical climate shifts. Plants evolved in a world with oceans. Their life cycles, their adaptations. Everything depends on relatively stable climate patterns that oceans provide. Without ocean currents distributing heat around the planet, you'd get these insane temperature differences. Coastal areas that used to have moderate climates would either freeze or cook depending on their latitude. Let me explain ocean currents for a second because they're crucial to understanding this. The Gulf Stream alone carries as much heat northward as 1 million nuclear power plants generating energy continuously. It moves warm water from the Caribbean up past the eastern United States and across to Europe. This is why London, which is at the same latitude as Calgary, Canada, has such a mild climate. Without the Gulf Stream, Britain and much of Western Europe would experience Siberian-style winters. We're talking temperatures dropping by 10 to 15 degrees Celsius on average. Places like Norway and Scotland will become nearly uninhabitable. But it's not just the Gulf Stream. The entire thermohaline circulation, sometimes called the global conveyor belt, moves water around the planet. Warm surface water travels from the equator toward the poles, cools down, becomes denser, sinks, and travels back along the ocean floor toward the equator, where it warms and rises again. This cycle takes about 1,000 years to complete and regulates climate across the entire planet. Break the system, and you break global climate stability. Inland areas would become even more extreme. Continental interiors, which already experience wider temperature swings in coastal regions, would see summer temperatures that could exceed anything life could tolerate, and winters that would freeze solid. We're talking temperature differences of maybe 80 to 100 degrees Celsius between seasons in some places. The Gobi Desert, which already experiences a 70-degree range annually, would see even more extreme swings. Central Asia, the interior of North America, the Australian outback, all of these would become absolutely uninhabitable. Monsoon systems would collapse entirely. The India monsoon, which 1 billion people depend on for agriculture, is driven by temperature differences between the ocean and land. No ocean, no monsoon. Southeast Asia, India, part of Africa, all the regions that depend on seasonal rains would turn to permanent desert. We're talking about the primary water source for billions of people just vanishing. The atmospheric pressure would change too. With no ocean surface, the areas that were once deep ocean basins would have much higher atmospheric pressure than what we're used to. See, our current sea level is defined by the ocean surface. Remove the ocean and the floor drops by an average of about 3.7 kilometers. Standing in the Mariana Trench, you have 11 kilometers of extra atmosphere above you. You'd feel atmospheric pressure about twice what you feel at current sea level, maybe more. It would be like trying to breathe at the bottom of a really deep valley, with all that air pressing down on you. Your body wouldn't be adapted to it. You'd feel sluggish, breathing would be labored, and the risk of nitrogen narcosis would be real even though you're not underwater. Meanwhile, on what used to be continental coastlines, now perched on cliffs overlooking the dried basins, atmospheric pressure would be lower than current sea level because the average surface elevation would be higher. The redistribution of atmospheric pressure would create insane wind patterns as air rushed from high-pressure basins to lower-pressure continental areas. Hurricanes and typhoons would be impossible without warm ocean water to power them, but you get new weather patterns that are equally terrifying. Massive dust storms from the dried ocean beds, carrying salt and sediment across continents. These storms would make the Dust Bowl look like a light breeze. The Dust Bowl of the 1930s displaced millions and created dust clouds that blocked out the sun. Now imagine that, but with salt-laden dust from dried ocean beds being whipped up by temperature-driven winds with nothing to stop them. These storms would sandblast anything in their path and deposit salt on previously fertile land, killing whatever agriculture remained. Salt is incredibly destructive to soil. Even small amounts can make land unusable for farming. Now we're talking about continental-scale salt storms. Entire regions would be rendered sterile. The salt would get into water sources, making them undrinkable. It would corrode buildings, infrastructure, everything. Let's talk about human civilization for a moment. Coastal cities, which house more than 40% of the world's population, would suddenly be sitting on cliffs overlooking vast dry basins. New York City would be perched on the edge of a cliff, looking down into what used to be the Atlantic. Tokyo would overlook the dry Pacific basin. London would be far inland from any water source. Mumbai, Shanghai, Los Angeles, Miami, all these major population centers would be stranded far from any water source. The logistics of getting fresh water to billions of people would be impossible. Consider that many coastal cities are at or near sea level. New York's average elevation is only 10 meters. Remove the ocean, and suddenly you've got a cliff face dropping down to the ocean floor, which might be 100 meters or more below the city. The continental shelf extends pretty far out from New York, but once you're past that, the ocean floor drops dramatically. Infrastructure built assuming sea level conditions would be useless. Trade would collapse. About 90% of global trade happens by sea. Think about that. Everything from the phone in your pocket to the coffee you drink probably traveled by container ship at some point. All those shipping lanes would be useless paths across dried seabed. Sure, you could theoretically drive across what used to be ocean floor, but the terrain would be incredibly treacherous. Underwater canyons, mountain ranges, fields of volcanic rock, deep trenches, areas covered in thick mud and sediment. And what would you be trading anyway when agriculture has collapsed and most people are struggling to find water? Modern civilization is built on the assumption that oceans exist. Our entire logistics network, our food systems, our climate expectations, everything. About 3 billion people rely on fish as their primary source of protein. That's gone. Rice paddies in Asia depend on monsoon rains driven by ocean evaporation. That's gone. Wheat in the American Midwest depends on rain from moisture that originated in the Gulf of Mexico. That's gone. Speaking of water, the total volume of water on Earth wouldn't disappear in this scenario. It would have to go somewhere. This is actually important to think through. If it all became atmospheric water vapor, the greenhouse effect would be so extreme that surface temperatures would skyrocket. Water vapor is actually a more potent greenhouse gas than carbon dioxide. If you suddenly put 1.3 billion cubic kilometers of water into the atmosphere as vapor, you'd create a runaway greenhouse effect similar to what happened on Venus. Venus, which is similar in size to Earth, has surface temperatures hot enough to melt lead because of a runaway greenhouse effect. Earth would head in that direction. If somehow the water got locked in ice at the poles or underground, you'd have a different set of problems. Massive ice sheets kilometers thick would cover polar regions. The weight would depress the crust. Underground, if water somehow got trapped in aquifers, it would be inaccessible to most life. Either way, the oceans would still be gone and the climate effects would be catastrophic. The planet's albedo would change dramatically. Albedo is a measure of how much sunlight a surface reflects. Ocean water is dark and absorbs about 94% of sunlight that hits it. Only about 6% is reflected. Dried ocean beds covered in light-colored salt and sediment will reflect much more sunlight back into space, maybe 40 to 60%. This might initially seem like it would cool the planet, but the loss of ocean heat distribution and the collapse of the water cycle would override any cooling effect. Plus, the dust and salt particles thrown into the atmosphere by storms would create their own effects on solar radiation. Tectonic activity would change too. The weight of ocean water actually affects the Earth's crust. We're talking about immense weight. A cubic kilometer of water weighs about 1 billion tons. Multiply that by 1.3 billion, and you got 1.3 billion tons pressing down on the ocean floor. This weight actually depresses the oceanic crust. Remove all that weight suddenly, and you'd see the ocean floor rebound upward. This is called isostatic rebound. We've seen it happen with glaciers. When massive ice sheets melted at the end of the last ice age, the land underneath rose up. Scandinavia is still rising at a rate of about 1 centimeter per year, 10,000 years after the ice melted. But this would be on a much larger scale and happening much faster. The sudden rebound would trigger earthquakes on a massive scale. Fault lines under the former ocean floor would suddenly be under different stress conditions. Underwater plate boundaries would shift. We're talking about magnitude 8 or 9 earthquakes happening frequently across the globe. The Ring of Fire, that horseshoe of volcanic and seismic activity around the Pacific, would go absolutely crazy. Underwater volcanoes, suddenly exposed to atmospheric pressure instead of water pressure, would erupt more violently. The change in pressure would affect magma chambers, potentially triggering eruptions from volcanoes that had been dormant. Volcanic ash thrown into the atmosphere would block sunlight, causing further temperature drops in some regions, while greenhouse gases from the volcanoes would warm others. The climate will be chaotic, unpredictable, swinging between extremes. Marine organisms have given us so many things we don't think about. Medical compounds like antibiotics and cancer treatments have been derived from marine organisms. Horseshoe crab blood is used to test vaccines and medical equipment for contamination. Coral reefs provide compounds used in bone grafts. Industrial materials like adhesives inspired by barnacles and mussels. Food, obviously, 3 billion people depending on it. But more than that, the ocean is the foundation of our food chain. Even if you never eat seafood, the collapse of marine ecosystems would affect land-based food chains in ways we can barely predict. Coral reefs alone support about a quarter of all marine species despite covering less than 1% of the ocean floor. They're nurseries for fish. They protect coastlines from storm surge. They support tourism industries. Lose the reefs and you lose all of that. The Great Barrier Reef generates about $6 billion annually for Australia's economy. Multiply that by all the world's reefs, and you're looking at enormous economic loss even before considering the ecological collapse. Seabirds that depend on fish would die out. Penguins, albatrosses, puffins, pelicans, all gone. That affects the terrestrial ecosystems they're part of. Seabird guano is a major source of nutrients for many island ecosystems. Remove that and island plant communities collapse, which affects insects, which affects other birds, and the cascade continues. Polar bears hunt seals on sea ice. No ocean, no sea ice, no seals, no polar bears. Walruses, sea lions, elephant seals, all the marine mammals would die. Whales, dolphins, manatees, sea otters gone. We'd lose some of the most intelligent and complex animals on the planet. Whales have cultures, languages, social structures we're just beginning to understand. All of that would be erased. The loss of the ocean's carbon sink will be catastrophic. Oceans absorb about 30% of the CO2 we emit, roughly 10 billion tons per year. This dissolved CO2 forms carbonic acid, which is already causing ocean acidification, a serious problem. But without oceans absorbing any CO2, atmospheric concentrations would spike even faster. We're currently at about 420 parts per million of CO2 in the atmosphere. Without the ocean sink, we'd see that number climbing much more rapidly, accelerating warming and making the atmosphere increasingly toxic. High CO2 levels affect human cognition and health. Above 1,000 parts per million, people experience drowsiness and poor air quality. Above 5,000 parts per million, it becomes dangerous. The carbon stored in ocean sediments and dissolved in seawater would also be released as the ocean dried. There are roughly 38,000 billion tons of carbon dissolved in the ocean, about 50 times more than an atmosphere. If that all got released as CO2, atmospheric concentrations would be lethal to most life. Night skies would change too. Without ocean surfaces to reflect the moon and starlight, without the moisture in the air from ocean evaporation creating atmospheric effects, without coastal light pollution from port cities that would now be dark, the view from dried ocean basins would be incredibly different. The higher atmospheric pressure in ocean basins would also affect how you see stars. The atmosphere will be thicker, creating more distortion. Though honestly, If you're standing in a dried ocean basin breathing toxic air in the dark, stargazing is probably not your top priority. Any remaining humanity will be forced to cluster around remaining fresh water sources. Rivers fed by mountain snowmelt would be precious. The Amazon, fed by rainfall and Andean snowmelt, might still flow, at least for a while. The Great Lakes would be crucial. Lake Baikal in Siberia, the deepest lake in the world, contains about 20% of the world's fresh surface water. That will become incredibly valuable real estate. Underground aquifers will be tapped desperately, but many of those are recharged by rainfall that ultimately comes from ocean evaporation. Without that, they'd eventually run dry. Wars will be fought over access to water, making current resource conflicts look trivial. The water wars of the future are sometimes joked about, but in this scenario, they'd be absolutely real. Nations would collapse. Millions, billions would die from dehydration, starvation, exposure, disease. The breakdown of society would be complete. The psychological impact would be profound too. Humans have always had a relationship with the sea. It's in our stories, our cultures, our evolution. We evolved from creatures that came from the ocean. The ocean is in our blood, quite literally. Our blood has a similar salt concentration to seawater. We carry the ocean inside us. Losing the oceans would be like losing a part of our identity as a species. The myths, the maritime traditions, the beach memories, the sound of waves, all of that would be reduced to stories told by the last generation that remembered. Children born in this world would grow up never having seen the ocean, never understanding what we lost. They'd read about it in books, if any civilization remained to keep books. They'd see pictures and videos, if any technology remained to view them. But they'd never experience the reality of standing on a beach, feeling the spray, hearing the rhythm of the waves. In the end, Earth without oceans would be unrecognizable. It would be a dead or dying world, unable to support complex life. The blue marble will become a brown and white marble, a testament to how crucial water is to everything we know. The oceans aren't just features of our planet. They are the planet's life support system. Without them, Earth would just be another barren rock in space, a dead world orbiting a star, or perhaps some scattered pockets of extremophile bacteria clinging to existence around remaining water sources. But nothing resembling the vibrant, diverse biosphere we know today. This thought experiment shows us something crucial. The oceans aren't separate from us. We don't just live near them or use them. We depend on them for our very survival in ways we rarely think about. Every breath, every drop of rain, every stable temperature, every fish in the market, it all traces back to the ocean. Protecting our oceans isn't just about saving marine life or preventing pollution. It's about preserving the systems that make our existence possible.